bit about that history to kind of contextualize what we're doing in this project. And then I'll conclude by talking a little bit about our future directions and where we're going with this. Just at the most kind of high level, what we're working on in this project is improving optical character recognition, OCR, for Arabic script languages. Now, OCR, if this is a digital humanities audience, so I would assume that most of you would probably know what OCR is, but in case you're not familiar with it, it stands for optical character recognition, and it's basically the technology that allows you to take a scan of a book, an image of a book, and then extract the text from it to produce a digital text, to make it searchable, to make it basically able to be manipulated by a computer. So the reason that we started focusing on this wasn't actually our initial focus, was because when we got started on this Persian digital humanities and this Open Islamicate text initiative, we realized very quickly that the biggest barrier to creating large machine actionable digital repositories of text was actually that OCR for Arabic script languages was very poor. There's a lot of programs out there that promise pretty high accuracy rates, but when you actually kind of try them on existing image scans of books, they don't perform that well. They don't perform nearly up to what they promise that they will. And then on the other side of it, there's some very complex computer science approaches to these problems that again promise really good accuracy numbers, but are incredibly difficult to use and are certainly not usable by kind of average humanities scholars who don't have the technical training to run these things from the command line and to put a whole pipeline together of a bunch of different scripts and manipulate text in that way. So what we really set out to do in this project was to take the latest computer advances in computer science fields like computer vision and natural language processing, and bring those together with a user-friendly pipeline and a powerful OCR engine, open source OCR engine, and that's actually very important. I'll come back to that point a little bit later, to make a user-friendly digital text production pipeline. So at the kind of high level, that's what we're doing in this project. So let me now delve into a little bit that history of the prehistory of this project, and then we will I'll talk a little bit more about the project itself and some of the details. Okay, so oops. Oh, there we go. Okay, so before I start talking about that, I do just want to I want to highlight the fact that this is a large team project. So I'm the PI, the principal investigator of the project, the director of the project. But it is a very large collaborative project that involves 4 other co-PIs, Sarah Savant at Aga Khan University in London, Maxime Romanov at University of Vienna, David Smith, who's our computer science lead at Northeastern University, and Raphael Viglianti, who's at University of Maryland with me, but is in the Maryland Institute for Technology and Humanities. We also have 2 postdocs that are funded through this grant, Jonathan Allen and Alejandro Toseli. And then we have a whole team jumping down one. I'll come back to the other collaborators. A whole team of graduate students who have been working on this project in various capacities throughout the last year and a half or so. We also have 2 large institutional collaborators. So Sharia Source, which is headed by Intisar Rab at Harvard Law School, and then the Scripta in America project, which is headed by Daniel Stokel. So we've been working with all of them towards this larger project goal. And this is one of the things, if you're in the digital humanities, digital humanities projects are typically highly collaborative because nobody has all the skills to do all these things. Okay, so without further ado, let's get on to talking a little bit about what we're doing here. So we, many years ago, started collaborating with a computer scientist named Benjamin Kissling. And Benjamin had been working with a digital humanities team at the University of Leipzig in Germany. And he was working on developing a new open source OCR engine called Kraken. And we kind of jokingly called Kraken then Acropos because it's a fork of Acropos that he then added a basically neural networking infrastructure to. And so what's kind of funny is that we met Ben at this conference, and actually over dinner after the last night of the conference, we were talking with him, and Ben, in his very computer sciencey way, was kind of like, yeah, OCR for Arabic script languages shouldn't really be a problem. And we're like, oh, really? That's great. Good to know. We would love if you could help us solve this problem. And he's like, yeah, send me some data and we'll do it. And so we produced some data for him, Maxime, Sarah, and I. And much to our surprise, the results that he got were much better. And the reason it was much better was because adding this new neural networking infrastructure to the kind of standard first, second generation OCR engines that did work very successfully for Latin script languages made a huge difference in terms of the accuracies that we were able to get. So, some technical jargon here, the neural network is a long, short-term memory neural network with a connectionist temporal classification. Honestly, these things are a little bit beyond my digital humanities knowledge, but if there's anybody who's a little more engrossed in the computer science world out there, that may be important for you. It works at the line level. This is a big thing. It did not require character level segmentation as the earlier OCR engines did, which made a big difference in the accuracy for connected script language like Arabic script languages are. And the biggest thing is that it was trainable. We were able to feed it training data in a relatively easy method to train it on new typefaces, which was something that the commercial OCR solutions do not offer, or at least not easily. There's some ways of hacking them and kind of doing it, but it very easily allows us to retrain it, which is critical for scholarly digital humanities projects because you're always going to be encountering new typefaces, and especially if you get to manuscripts, as I'll talk about later. The other big thing I want to point out about this is that it's open source, and this is one of the things that I feel incredibly passionately about, and I really I kind of proselytize for, is that I think in the digital humanities community we really need to be working on open source tools so that those tools can be reused and adapted by other scholars and other cultural organizations in the future without paying some type of high technology cost. So all of the projects that we have gotten funding for, we always, in fact, many of the funding institutions require it that it be open source. So let me go on. So we did some initial tests with Ben, and I'm going to move through these pretty quickly. I'm more interested in telling you the kind of story behind this rather than focusing on all the details in every single figure here that I have. We basically tested Kraken on 7 Arabic books representing different typefaces that were what we would describe as varying levels of difficulty. We were pretty astonished that we got between 97 and 99% accuracy on all the typefaces with about 1,000 lines of training data. And we actually found out that image quality was not really as important as we first believed. Now, these numbers, this was probably 2 years ago or 2.5 years ago at this point, maybe even 3 years ago. At that time, these numbers were quite striking to us because at that point in time, when we had used commercial OCR solutions, or we had tried using Tesseract, for example, we could get nowhere near these numbers. And although the process of generating 1,000 lines of training data is pretty laborious and it's not insignificant, if you're somebody, maybe some of you are, I'm not sure if any of you here are graduate students or scholars working on books on projects, but if you have the choice between you really have a book that you want digitized to high level of accuracy, and you have the choice between generating 1,000 lines of training data, which may take you a few days, and then getting a 98 to 99% accurate text as a result, that saves you an enormous amount of time in your research process, because you'll be able to search around in that book, find things quickly, do all this. And so it's really not a huge ask, actually, if you want high accuracy transcription to do this. So this was definitely a big step in the right direction. And you'll just see here some of these examples, and I just want to point something out. And I'll move through the rest of these pretty quick, but what you see at the very top line here, this one, Ibn Fathi al-Buldan, you'll see this says training. Can you see my cursor, by the way? Is that also coming through? Do you see the cursor?
Yes, we do.
Yes,
okay.
sir.
Okay, great. So you see this is listed as the training set. So what you see here is that if we use training data from this typeface, we were able to achieve, these are different kind of model settings that we use, but if in this one model setting, we were able to achieve 97.5%, 0.56% accuracy if we included white spacing errors, or if it was just on the Arabic script itself, it was actually well over 99%. And then what we did, the rest of these numbers you see in here are actually then taking the model that was trained on this book, on the training data produced from this book, and then using that model to transcribe the other ones. So as you see, these accuracy rates are not as impressive, but it's using a model from a different typeface on these books. Surprisingly, actually, some of the books did okay. You see these book number 5 and 6 down here actually did pretty well, even with a model trained on a different typeface. So what you're going to see here in the following slides here is basically we just shifted around and trained models on each of these books and then tested them on the rest. But the larger takeaway point here is you can see whichever book we had the data for, we got really high accuracy rates. So 97, over 97, over 98, over 97, over 99. And yeah, I didn't put up these last two, but in any case, the point is that we were able to consistently get really high accuracy rates. This study attracted interest from several people. So JSTOR, I'm not sure, are you familiar with JSTOR? Does JSTOR operate in India? I'm not sure.
Yes.
Okay. So JSTOR was very interested in this because they had received a grant from the National Endowment for Humanities in the US to study adding Arabic script journals to their large digital library. And so they, unsurprisingly, kind of came to the conclusion at one point that the number one obstacle was that they needed really high accuracy OCR, and it didn't really exist. And so what we did is we actually partnered with them on a study looking at Al-Abhath journal, which is probably the most important Arabic medium scholarly journal in the Middle East, published out of American University of Beirut. And we went through, we did a study of their typefaces. We generated close to 7,000 lines of training data. And then we did some tests, and they did some tests. We also did a Persian study, which I'll come back to in a second as well. So the result of this study was that they actually took our data that we produced, and they actually had an outside contractor verify the accuracy rates. And the results were that we achieved, they had previously come to the conclusion that Abby Fine Reader was the most accurate commercial solution. And so they basically tested that versus ours. And they ended up coming out to the conclusion that we did about 9 to 10% higher in terms of accuracy than Abby, which was excellent, because this is a open source OCR tool, so it's not as expensive. Abby is quite expensive, and it's also not very trainable. So we ended up with a total character error rate of 97.4, or Arabic script only error rates of 98.46. which they were quite elated with. We also did some Persian tests. So we've been operating largely in Arabic, just kind of because that's what our different collaborators were using. But myself being primarily a Persianist, I was very eager to get into Persian. So we, in collaboration with a couple other colleagues, we did some tests. And similarly, you're seeing these rates above 90. Well, this is above 96. Persian has not been quite as good, although we've now improved these, but quite respectable numbers. So this is all the prehistory. What this work did is it eventually attracted the interest of the Mellon Foundation, who had decided to prioritize working in digital humanities outside of the kind of main European literary traditions. And so they invited us to submit a proposal for this OpenITI AOCP project. And their idea, what they wanted to do is they wanted to really take the work that we had been doing and improve it, but also make it more easily accessible. So you didn't have to collaborate with a computer scientist in order to get it done, as we were doing with Benjamin Kissling. I'm going to talk about a few of the outcomes of what we're doing in the OpenITI AOCP project, perhaps I'll split them in half into like what we call the digital humanities outcomes and then technical outcomes. So the main things that we're focusing on in terms of digital humanities outcomes in this grant are producing a Persian and Arabic typeface inventory, which is basically a study of the typeface history of Persian Arabic, of Arabic script languages. And we've actually branched out into Ottoman Turkish and Urdu as well, because the typeface histories of these languages are very much interlinked and overlapping. And as you probably know, so much Persian printing was done in India in the 19th century and even early 20th century. And so it obviously overlaps significantly with Urdu as well then. So the typeface inventory, the idea is that if we know which typefaces are most common and most prevalent, we can focus our training data production to make sure that we are meeting the greatest need in terms of having a base of training data that will produce the highest level accuracy OCR. So, and it will also, what it will become is also a kind of a machine actionable, it would become like a machine actionable training ground for the automatic model selection, which I'll talk about in this next slide. So this actually is almost done. We're pretty far along in this. Obviously, as part of this project, we're going to be generating a lot of training data. We currently have around 35,000 lines of Persian, Arabic, Ottoman Turkish, and Urdu training data that is partially released, and the rest of it will be coming soon. Probably by the end of the project, we may even have closer to 40,000 lines. The other big deliverable from this grant will be a corpus pilot. And so we'll be actually running about 100 Persian, 100 Arabic works all the way through this digital text production pipeline that we're working on, and exporting them. And this is really important, which is the next bullet point, into TI XML. So Raf Viglianti, who I mentioned earlier, who's a co-PI on this project, the big thing that he's working on is basically producing a conversion tool that will allow for text export from the pipeline that we're working on, from Alto and HOCR, which are these kind of standard OCR formats, into TI XML, and also into OpenITI Markdown, which is a type of Markdown that we use for research purposes within the larger OpenITI project. The kind of most high level outcome of this would be a digital text production pipeline. And What I'm going to do is at the end here, I'll pull it up, and it's in a different window, so I won't out of the presentation right now, but I'll pull it up and I can just kind of give you a preview, a very, very early beta version of what we're working on. But you can see in some of the screenshots that I've been showing what it looks like in the most general sense. Okay, so the next set of outcomes are actually what we call the technical outcomes. And basically what we're doing is we're working with David Smith and Alejandro Toseli of Northeastern University to integrate the latest advances in NLP and computer vision into a much more dynamic OCR pipeline. So, those previous results we talked about were basically just using Kraken, the OCR, tool Kraken to get these results. But there's actually a lot, and this became very clear in our early conversations with David around this project. There's actually a lot of work that's been done in other areas of computer science that could be put to use in a OCR pipeline to do some really interesting things. And so I'll talk through each of these, but the basic overall push here is that we want to be able to move towards greater use of unsupervised methods, towards greater use of basically automatic methods of achieving the things that previously we have been doing by hand, individuals doing by hand. So the first one here, create ground truth by automatically aligning dirty OCR with existing digital editions. Okay, so what does this mean? What we're doing here is, and this is really work that David Smith has pioneered, is using, he has recreated already, these interesting kind of text alignment programs that originally were built off of like plagiarism software, basically, that was used to detect overlaps in text. He's developed it in a completely different direction and has created this algorithm called PASM that he's used for several different interesting research purposes. But we realized that one of the things that would be a great use for this is actually asking the algorithm and fine-tuning the algorithm and expanding it so that it is able to take a digital text of the work. So we have a lot of digital texts of varying qualities, both Persian and Arabic, and then actually asking it to try to find alignments within dirty OCR. So even if the OCR is not that accurate, I'll talk about this a bit later, we've actually been doing some more recent experiments with manuscript OCR, in some cases only getting 30 to 40% accuracy, but using this automatic alignment algorithm, actually still we're able to align up to 50% of the lines. Now, what happens when you align the digital text lines with the dirty OCR lines is that you basically create training data. You just have to tell it that the digital text alignment is the accurate transcription, and then you get substantially accurate. There's some qualifications here because there are some differences sometimes in text, but you get an enormous amount of training data produced very quickly using an automatic method, basically. Okay. So the next thing that we're working on is improving layout analysis. So anybody who's worked with OCR knows that this is always a problem. There's some new work in computer vision that David believes is really going to help us improve layout analysis. And we've started working on this, and some of the results are quite impressive. We're trying to move towards not just region segmentation, but semantic segmentation. So being able to understand the difference between footnotes and body text and things like this. The other thing that we're doing kind of similarly on this move to unsupervised work is automate offline OCR retraining. So currently this is a user initiated process to initiate the retraining of the OCR models. We want to move towards having that just happen in the background, so the models can be continuously improved without needing to to be basically have a human intervene and initiate the process. Similarly, developing unsupervised confidence measures for OCR output so that the user, when they OCR text, they can be given an approximate estimate of where the text might stand as a whole in terms of accuracy. And then on a similar vein, enabling the system itself, allowing the system to do unsupervised model selection, combination, and adaptation. And again, this is all trying to automate processes that currently humans have to intervene and do. And in particular, in this case of model selection, as we get more and more models and more data, it's very unclear whether or not this will actually be a positive thing to have humans intervene and do the model selection. There's also, I just want to put a bit of a star here, because the other issue is that this idea of model selection at least, assumes that we'd be using typeface specific models, and that may, in the end, not be what we're doing. We've been working with both typeface specific models and generalized models that combine features of all different typefaces. And the jury is still out a little bit, but it just looks like generalized models may be more accurate. So that may or may not be an issue. And then finally, working on mixed language models. So for those of us who are working with medieval Persian in particular, the presence of a lot of Arabic in there creates a lot of problems sometimes. Also, when we worked in the journal project with JSTOR, this was also an issue, because there would be frequent English words or even English quotations in the middle of the Arabic, which would cause problems for the recognition. So, okay, so these are the main kind of technical components of what we're doing. Now, I want to say a couple words about where we're moving and what we're doing next. So all these things that I just talked about were either things, some of that was prehistory, things we did before the OpenITI AOCP project. The last two slides were really focused on what we're doing in the AOCP project, and we're about 2/3 of the way through. So many of these things are either done or well on their way. So we're already thinking about next steps, and I just want to give you a little preview of that before we stop, and I can try to give you a little bit of a live shot at the digital text production pipeline that we're creating. Okay, so next step. So what we're really interested in moving to is manuscripts. In this, when you make that move, you move from the domain of OCR to HTR, handwritten text recognition. For those of you who work on anything pre-modern, the size of the manuscript tradition for Persian and Arabic is so enormous. It's really even difficult to fully quantify. We just have very rough estimates. But some people who are specialists in this have commented that probably only 5 to 10% of the Persian and Arabic written tradition has actually been published in print. The vast majority of it, regardless of what number you go with, is still in manuscript form. And this is a huge cultural record that we hope through working on HTR for Arabic script manuscripts, we can help make more visible and make more usable. What we're doing, the issue that we started to confront with OCR becomes an even larger problem with HTR and manuscripts, and that is that there's a finite number of Arabic script typefaces for Ottoman Turkish, Urdu, Persian, Arabic. We could theoretically generate enough training data to eventually get accuracy rates on these print texts to high levels. It's not cheap. It takes time and all these kind of things, but it's very doable in a larger sense. Now, we talk about manuscripts. This becomes a complete non-starter. We're never going to be able to generate enough manual training data to correctly recognize all different manuscript hands, styles, layouts, all these issues that come up. The level of diversity is so much greater than it is for the print tradition. So as we started to move into this field, we took a look at the work that had been done, and there's been a lot of great work that's been done, but the biggest drawback to it all is that it relies on this model of having individual scholars, and most of the time they have to be scholars. It's very, unless you have training in paleography, it's not always that easy to interact with manuscripts and correctly transcribe them. So you need somebody who has some training in this. They at the very least need to be a well-trained student in these areas. And so you have these people working on generating these huge numbers of training data, which is incredibly time-consuming for one manuscript. It's just not a model that can work moving forward if we're going to actually get to a point where we can do relatively decent automatic transcription of manuscripts. So both these projects that I'm going to talk about right now are moving in this direction of using unsupervised methods to generate training data to automatically to generate training data in an unsupervised manner so that we can more quickly improve transcription for Arabic script manuscripts. So the first one is the Automatic Coalition for Diversifying Corpora program. This is an extension of what we are doing with the text alignment training data production method in the Melon, but it's moving it to manuscripts. And as I already mentioned to you, we found in some early experiments that we can correctly align up to 50% of the lines in a manuscript with dirty OCR that is only 30 to 40% accurate. We're able to then take a digital text and align up to 50% of the manuscript, which is a significant amount of training data. That right there in that process gives us enough training data to then accurately transcribe the rest of the manuscript. The rates vary and we need to fine tune it, but we're getting at least up in the 80s, which is as good or better than what is being done in these other projects in which the process of training data is this manual, weeks-long process of generating dozens of pages of manuscript training data. So we're really excited about that. We have a proposal in on it. We'll see what happens. The second one is called the Textual Lacunae Reconstruction Project. And basically, this is an effort to use this field called inpainting, or this technique called inpainting, that basically, to put it simply, if you think of if you had an image, a digital image of something, and let's say you had a digital image of a face. And what the textual lacunae reconstruction and inpainting method does is it says, okay, there's huge numbers of images of faces out there in the internet, for example. Let's pull all of those, and then let's tell the algorithm to just punch holes out in these images that we have, and then learn based on the kind of like what has been punched out and what then it looks like when it's punched out, how to reconstruct automatically in an unsupervised manner, reconstruct these images. So it takes this, plentiful source of data that we have, images of faces on the internet. It then creates its own training data by punching out randomly holes and then asking the algorithm to learn how to reconstruct the faces. And the results are quite good. They've had a lot of success with this, doing this on images. And so in our conversations, we had a large workshop in January, right before the whole COVID thing hit. And one of the people who has been working on this was there. And he said, there's no reason we can't do this for language, for images of text. The concept is the same. you need to take existing images of text, run it through one of these algorithms, and then ask it to basically learn how to reconstruct these same patterns. It's probably going to be a little more difficult than faces, but the foundational technology or technique should be transferable. And so this is another project that we've begun working on and have some funding proposals in on. So as you can see, we're moving towards manuscripts. We're also trying to move more towards utilizing unsupervised approaches because we really think that that's the only way, in particular for manuscripts, that we're going to be able to get to a kind of scalable and more generalizable transcription method. So, okay, oops, sorry. Okay, okay, there we go. I think I'm done here. So anyway, so that's kind of what we've been working on in the OpenITI AOCP project. Would it be useful if I just spent a few minutes just giving you a little live preview of the digital text production pipeline that we're working on?
Of course, of course.
Okay.
We enjoy that.
I'm going to stop sharing this PowerPoint, and I'm going to open up that so we can show you this. And hopefully it works because it's always a bit of a scary process when you're about ready to do a live demonstration of a tool that's in kind of beta testing or beta release, but it's been pretty stable, so hopefully it works. So let me share now with you. Oh wow, okay, I'm seeing a lot of questions here on the thing. Okay, let me do this and then I'll get back to that. Sorry, I wasn't paying attention to the chat window. Okay, so let me open this up. Okay, all right. So you see something that says eScriptorum here? Is that? Oh no, sorry, it's not coming through.
The screen is still loading for us.
Yeah. Okay, hold on, just 1 second. I see that it's. Huh, I'm not sure what it's doing. It seems to. Okay, is it up now?
Also, not yet.
Okay. What are you guys seeing? Right? It says I'm screen sharing. That's why I'm not sure what it's doing.
It says you've started screen sharing.
Yeah.
So I'm assuming that it's still loading. Do you want to cancel the screen share and then do it again?
Yeah, let me try that. For some reason, it's not giving me the ability to stop it. It's giving just a, oh, there we go. Okay. Sorry, just 1 second. I'm really not sure what this thing is doing. Okay, are you seeing the eScriptorum?
Yes, yes.
Now? Okay, all right, good. Okay, so right now, so eScriptorum, as I just kind of gestured towards earlier, is a collaboration between us, the Scripta Numerica project in Paris, Sharia Source, and then there's actually 2 other European projects, the Vietnamica project, and then a project through the National Archives of France that's now on board. So it's a large collaborative project to produce basically a user-friendly interface for doing OCR and HDR. So we right now currently in the AOCP project are primarily focused on OCR for print, but the original project, the Scripta Numerica project, actually has been focused on manuscripts. And so a lot of what attracted us to working with them on this was the fact that they have a lot of functionality built in already for HTR. Okay, so right now this is pretty much, the entrance to it is pretty plain. It will eventually be integrated into our website, and it will be, as they say, branded to the different organizations. But right now it's just kind of this generic landing page of eScriptorum. But if you go to my documents, you get all these different documents that that have been uploaded. And so, you can create a new one and upload your own, putting in some metadata. If you're doing region segmentation, you can actually define your own ontology. You upload, well, it's not going to let me upload the images unless I fill this whole thing out. But let's just do this real quick. Let's just say it's Arabic, left to right, blah, blah, blah. Okay, so then I can go to create, which will then allow me to move to images, and then you can just basically drop the images in here. Once you do that, you have these different options over here to transcribe, to segment. You can do binarization, although this is less important now. And similarly, if you had images in here, I'll show you how this looks when you actually have images in here. You can also do export and even actually import transcriptions as well. If you already have transcriptions, you can import them and view them in here. So, but let's go back to one that's actually uploaded. And we can, let's see if this one is properly updated. So you can see this in Behaki, and the kind of basic metadata has been entered here. This is actually something in this project we're working on, is actually elaborating more fully this metadata, but for right now it's just kind of simple. You can see here that these images have already been uploaded and transcribed. So let's just go here. This display issue is something that we're working on. But you can see here, these are the line segmentation that has been done. You can also, if you flip over here, you can open up individual lines. And one of the things that you'll notice here is that we're not working with rectangular bounding boxes anymore. Ben Kissling, who's on the Paris team, has implemented polygonal line segmentation, which is particularly important with manuscripts, though it helps to some degree, especially with early Arabic printing. And you can do your transcriptions here. This one is quite accurate. I think it may have even been corrected. We can go down here and actually see the history. So no, actually, I guess this one has been largely produced by the OCR. But you can do your transcription here. You can do your corrections here, and then you can then export the transcriptions in whatever format you want to export it in. Currently, it's just an alto or like a plain text or page XML. What we're doing as a part of the OpenITI AOCP project is you'll be able to export it in TEI and OpenITI Markdown. Probably a PDF option will also be enabled for those who just want some type of readable document. And you can also, and this is the other really interesting thing, is that you can also actually retrain models in here. So if you go in and select these, you can actually then ask it to train a segmentation or a new transcription model. Now, here's what I will say is that this is a very basic kind of platform that we have right now. What we focused on in the beginning of this work was basically so to make a long story short, we were actually working on a different platform first, and then we joined with the eScriptorum project, Daniel Stokel's team, to start working on this. And a lot of what has been done in this is building in the basic functionality. The thing that we're going to be focusing on in the next year is actually creating a much better user experience with this. So creating a more ergonomic, more design-focused user experience right now, my concern with this is that it's quite powerful. You can do a lot. And I'm honestly not even doing justice to all of it because there's a whole suite of functionality that's there for working with manuscripts that I actually personally barely use because it's not what we're working on right now. But if Daniel was giving this presentation, he could show you a whole host of other functionality that you can work with when you're actually have the page open. But it's not the easiest thing to use. And so we're going to be actually focusing on improving the user and design experience basically over the next year or so. But the functionality is there to do OCR, and you know, if your primary goal is to get something OCR, even manuscripts, doing HDR, all the tools are there to do it. The tools are there to train segmentation models, to train new OCR HDR models, which to be able to do that without having to work from a command line OCR tool is huge. I mean, I wish 3 years ago I could have done that. I really wish when I was working on my dissertation, I could have actually, you know, digitized several of the books that I was working on by training some models and creating, you know, nice digital transcriptions of them. So I'm going to leave this here. The only other thing I wanted to show you that I forgot to mention when we were talking about manuscript, the manuscript work that we're working on is if you look here in this little picture up in the upper right corner that I'm kind of circling around here, one of the really exciting things for those of us who are interested in manuscripts is that Benjamin Kissling has created a new baseline detection method that addresses these issues in manuscripts like this one, where you have the final word gets, you know, it can actually be at a slant this way, it can be at a slant this way, basically this bunching at the end of lines. And so much to all of the humanists' surprise, Ben was actually able to devise a baseline detection method that addressed this. And so we do have, between this new baseline detection method and the polygonal line segmentation, we have, I mean, basically Ben, really, not I don't want to say we, but Ben has dealt with some of the really significant problems that existed for OCR applications to manuscripts. So anyways, that was a lot that I dumped on you. I want to you know, open it up for questions and conversation around this. And I hope it was somewhat interesting and not too much information.
Thank you so much, Dr. Miller. That was such an instructive and highly fascinating session. And thank you for giving us the history of OCR, and in particular, telling us, you know, about the collaborative, multi-institutional, you know, kind of effort that has been, you know, going on to construct, you know, this scholarly corpus of the Islamicate text. And, you know, for this, you know, bringing together the macro textual analysis and bringing on the digital scholarship and the knowledge and the computational analysis of all these NLP and the computer vision. Thank you so much, sir. I will read out the questions for you.
Okay.
Yeah, so we have 3 questions from, you know, Walter Hakala. And he said, how do you tokenize the text? How does your OCR engine deals with diacritics? Is it capable of diacritizing unmarked text? Persian orthography has been relatively stable over the last 1,000 years. What challenges are posed by vernaculars whose orthography is subject to greater variation? What challenges are posed by the preference in South Asian Arabic script print history for lithography over movable type? So would you like to answer to Walter, sir?
Yeah, so let me start in kind of reverse order. So what challenges are posed by the preference in South Asian Arabic for lithography? Yeah. Okay. So yeah, we actually took up this issue of lithography in the very early part of the OACP project. And we basically came to the conclusion that we need to treat lithography almost as pseudo manuscript, in the sense that the way that it's produced was not going to lend itself very well to this kind of manual generation of training data process that we're following with printed works. And so we actually are going to work on lithography and these two proposals that I mentioned at the end that we have in for funding, and hopefully they work. Lithography is going to be included in that. So I think that it'll actually be, if these unsupervised methods work, I think that lithography could be kind of the like manuscript light, in the sense that it is a bit more regular in a certain sense, but then you still have the issue of it being found, fundamentally based on a handwritten document in a certain sense. So so that certainly would be an enormous challenge for the approach that we're taking with printed works. But if these unsupervised methods, these kind of automatic text alignment method or this in-painting method works, I think lithography could be dealt with quite well. The challenges by vernaculars or lithography is subject, yeah. I mean, this, it's interesting. I don't know. You all can tell me, because I don't work in these vernaculars, and so I'm not really able to compare necessarily the changes in orthography between them and, for example, the like pretty wide variety of scribal hands and script styles that you see in Persian and Arabic. I mean, there are some pretty significant differences. Now, I don't know if what you're talking about, how much larger the differences could get, which I imagine they can and do. But I think in either case, it makes a stronger case for moving to these unsupervised methods and really investing time and energy there, because
may I ask, just
yeah, please.
Does the engine, basically, just simply put, does it look at letter by letter, or does it look word by word? Does it require the engine to know what the entire token is, or is it so there's no predictive model based on the lexeme, right?
No.
I see. So in some ways, it doesn't care what language it's in. It just cares about the script.
Yeah, I mean, all these methods are language independent, so they could readily be applied to another language, because it's not based on a token or a lexeme. None of these things are important. The only thing that we're doing that does kind of engage with that to some degree is basically using Arabic Persian dictionaries on the other side of language models, basically, to try to recognize cases in which there's a uncertainty within the model about whether or not it would be this word or this letter or this word or so forth and so on. But that's really on the other side of it, not kind of baked into the architecture of the OCR or HDR engine itself. Does that make sense?
Absolutely. So that would mean that the shifting orthography of vernaculars wouldn't matter, except that, of course, the characters that are used do change over time. But it wouldn't matter because you wouldn't be looking for particular word types. You're just looking for certain characters within them.
Yeah, I mean, it just thinks they're patterns. That's what it's about, finding patterns, basically. And so it is an issue in the sense that you can't use training data, obviously, on one very significantly different script or orthographical style and then use it on one that's totally different. It's just not going to work. But that's, of course, why these unsupervised methods hold a lot of promise, because they don't depend on you generating data. You just need to throw as much raw data at it as possible, and let it figure it out to the extent that it can. But we'll see. I mean, these are still experimental, so I don't want to overhype them before we see what they can do. Sorry, was there any other questions in those first set that I missed?
There's one by Professor Nishad Zaidi. Can you give a few examples of successful usage of this OCR in Urdu language texts, especially when many of them draw lexical notes heavily from Indian languages?
So with Urdu, so we just started working with Urdu. So last couple months, we had one of our graduate students generate a couple thousand lines of training data for Urdu, and we also a group Foreman Christian College in Lahore has actually reached out and offered to do some training data production. So we haven't done a lot on it, just because the AOCP project initially was focused on Arabic and Persian. I will say, however, that in the initial tests we were done, the accuracy rates are much lower on Urdu than they have been on Persian and Arabic. But it's a little hard to tell what's going on at this point, just because, like I said, we literally have just started experimenting on it. So if you ask me in about 6 months, I'll have a much better sense than I do now. I mean, I know that there's definitely been some work on OCR and Urdu. My understanding from the review of the literature that our postdoc and graduate fellow did was that there is no currently existing OCR solution that works, great out of the box for Urdu. So my sense is that it's the same issue that we faced in Persian and Arabic, that there's a lot of work to be done. We need more training data. We need more focused research time on it to figure it out, basically.
Yeah, thank you, sir. There's one comment by Rohan. Rohan has said that he is using Kraken for Devanagari to read Hindi. Till now, he says, we have trained models for 3 different typefaces in use between 1890 to 1940. So 1200 to 1600 lines of training data each. The best is at 99.60%, so really promising. One of the problems we have encountered is page layout. Currently, Kraken supports single column layout. Is there a way to achieve more accurate line segmentation for 2-column layout with Kraken? Also, please share your experience with post-processing. I've found a workable solution with regex, but I'm hopeful there's an unsupervised way as well. To be clear, I mean cleaning the inaccuracies in OCR. I do regex for whatever pattern I see and then proofread.
Yeah. So yeah, page layout issue. The struggle is real. It's something that we've encountered, and that's one of the things that we're working on in the AOCP project. So I also know Benjamin Kissling, who's the creator of Kraken, has done some more work on different using this new baseline detection. He's improved the page layout segmentation a lot. The one thing that I know that is still a problem is what would you call, what's the kind of word? I guess like this semantic layout in the sequence. So like understanding if this column like reads top to down and then goes up top to down, making sure that the system understands that order is something that you really have to train a layout analysis model on, because there's really no way for the system itself to know what order it should be read in, unless there's training data to tell it that, to number the lines in that way. It does do bi-column recognition. I've used it on some Persian manuscripts, where if you're familiar with Persian manuscripts, poetry in manuscripts, it's typically in a 2-column format. It will recognize the two columns, but it just reads it straight across. If you want to separate out the columns, then that's another issue. There are ways of generating layout training data that could then teach it to recognize it in a different way. But out of the box, it's not going to do that. That's something, honestly, I think this is one thing that has, it's partially just based on what the research team that Ben is working on is doing. So because Ben has never worked with the newspapers with Kraken or other formats of text where you need to be able to basically have layout models that tell the system how to, semantically associate different regions with one another. It's not something that's come up as much, but we've talked about it, and it's doable. It's just, again, it's this issue of training data. Some of the stuff that we're doing should also help that, because we're working on semantic segmentation and layout analysis as well. I don't know if it's going to completely solve that problem, depending on what kind of text you have in mind. Oh, I'm sorry, in post-processing. Okay, so we have only focused on this in doing what I was just mentioning to Walter's question about using language models to basically correct or to encourage the system in certain directions, which I don't know exactly if that's technically post-processing, but we've never used regex expressions or anything like that, primarily because we've been operating on the assumption that that may be something that the individual user wants to do, but in terms of producing a pipeline, it's not something that we can regularize for everybody's experience. So that's not something we focus on, but you could use language models to help do some correction. Have you ever tried that?
If I can, I have used this to work on text that I am to use in my dissertation. So with that respect, we are training models, and I think, as I explained, 3 typefaces we have prepared. So currently I'm working on literary history in Hindi, where it's around 1500 pages. I think it's in 3 volumes. So there, what happens when you train the model is that there are certain characters that are usually missing from the model that we are training, and it would generate a list of those characters that it has not been able to pick up. So when you use that model to do the OCR, those simply because they are not present.
Oh,
I think so. We have lost him. We have lost Rohan here.
Oh, okay. I'm sorry.
Yeah, the connection, I think so. It's gone.
While we're waiting for him to maybe reconnect, Walter had one other question up there that I didn't address about diacritics. You want me to just comment on that real quickly, and then we can see if Rohan joins again. Sorry, just trying to find this. Oh, okay, diacritics, the table of diacritics side. In our text. Okay, so yeah, this has been a bit of a point of contention within our own team, actually. In the beginning, we actually generated the initial set of like 8,000 lines of training data without diacritics, because Maxime, if you know Maxime Romanov, felt very strongly that diacritics are in computational textual analysis are almost always removed, and so they're not helpful for producing typically normalization of the text for computational textual analysis. They're normally removed. Maxime also has a very
just in Arabic context.
Just in Arabic, yeah. I'm not.
Well, because again, Arabic morphology allows that, but not South Asian morphology.
Interesting. So yeah, I don't know anything about South Asian morphology. So yeah, that could definitely be a big problem if you. But listen, I mean, here's the thing. So we removed them. I'll tell you what our experience, and then I'll say something to your situation. But we removed them initially for those reasons. And then we kept them in the Persian, and then in more recent Arabic texts, we kept them in. And what we found, I think actually will speak to your situation, is that if you remove enough of them, that the system can learn that these little diacritics, these little, for the system's point of view, they're just lines on, it doesn't matter what they are to the system. If you remove enough of them, it learns to ignore them. And then it ignores them successfully, and it doesn't mess up your OCR. Now in Persian, we kept them in, but I don't know, Walter, if you do any work, or anybody else here does any work in Persian, you'll know that there's a lot less diacritics in Persian. They're relatively infrequent, actually, but we kept them in. But then we had the problem where we found actually that anywhere there was diacritics was messing up the OCR, because there wasn't enough diacritics in the training data to actually teach it correctly to recognize the diacritic in the context of the line, because it's not tokenizing things. So it recognizes, mim, dhamma, sin, or something like that. It doesn't actually recognize it separately. So you need enough of it so that it actually recognizes that combination, that pattern. And so it actually created a lot of problems in our Persian data, which is why our accuracy rates in Persian, one of the reasons they were lower, is because basically anywhere there was diacritics, it messed up the OCR. So we did this in Arabic. Now we kept them in, and it recognized them fine when there's enough of them there to teach it correctly how to recognize it. So I would imagine in your case, I'm not sure what all languages are you working on?
Well, I work with Persian and Urdu, but in the case of Urdu and Persian as well, you have a lot of homographs that are etymologically unrelated, right?
Mm-hmm.
So without diacritics, two words may look the same, even though one may be of Semitic origin, one may be of Sanskrit origin, and so they look the same, but actually mean completely different things and are unrelated. And in my case, I'm always trying to build up a corpus of individual terms for concordances.
I see. Yeah.
So often writing it in Roman script is helpful as well, because South Asia is also multi-script. More people read Urdu in Devanagari script than in Urdu script.
I see. Yeah.
Which is also another thing as well.
Yeah. So I'm less familiar with Urdu, but my guess is that it's probably a little bit closer to the Persian example, right? I mean, in the sense that there's not an overwhelming number of diacritics. It's not like, the examples that we were working on were medieval Arabic texts where you have a lot of diacritics in it because they're quoting hadith and they're quoting the Quran and they're, and so you have this heavily diacriticized.
I guess the texts that we probably mostly deal with don't have diacritics in them, but if we were to transcribe them into a different script, like Roman script or Devanagari script, we would need to know what those diacritics are to give an accurate phonetic representation of those words, right? Otherwise, it's just otherwise you just have consonantal skeletons, basically,
right? Without
knowing what the vowels are.
So, I mean, there's definitely no way the OCR engine cannot insert these things. I mean, I think some of these things are like the work that morphological analyzers would be doing, right? Where they can parse words but I don't even know. I don't know. Does Buckwalter actually vocalize Arabic? I don't think so. I don't know if you're familiar with Buckwalter, morphological analyzer. I don't even think it can do that. I know that there's some work on in natural language processing on this issue of how to vocalize unvocalized text, but it's really tough because you need like language trees, and you need all these different things to basically feed information into it so that it can know, well, that can't be a passive verb. It has to be an active verb because there's no direct object in the sentence. Therefore, it has to be vocalized this way. And this kind of stuff just does not exist for Persian, Arabic, and Urdu, at least to my knowledge. And so, in Greek and Latin, they have these things because they've been working on these things since the 1980s. I mean, literally, like Perseus Digital Library and all this work that came out of it was started in like the early 80s, which I don't even understand. I don't even know what they were like putting these things on. Like, so like this, we're just much further behind in that. So I think you would need something like that if you actually wanted to generate vocalization.
From what I understand, big digitization projects that involve the transcription of text, because the cost of labor is relatively low in India, it's been possible to actually just hire humans to type out text. And that's often been more cost efficient than OCR technology, which is so complex and requires, so that's, I think at this point, it still remains cheaper to have human hard coding than to actually OCR South Asian text.
I mean, that's exactly with Jamia, the Arabic online repository of text. I mean, that's the conclusion that Maxime and a few others who have really looked at it, is that it's mostly double keyed, basically, just having people key it in. I mean, there's all sorts of like labor issues and things like that go into this kind of thing, but and ethical issues, but it's but yeah, I wouldn't dispute it. I mean, it's quite possible. I think the only promise is that I think for print text, these kind of things are much easier. When you get to manuscripts, I think this is where things get a little bit more difficult, because I don't know the situation exactly in India, but working with some of these manuscripts, it's not even easy. Undergrads can't really handle them. Graduate students still need paleographic training in order to be able to handle them. It's really tough to hand key to manuscripts, and so that's at least why we're moving in that direction, I guess.
Thank you, sir. Thank you so much for answering all our queries and addressing so many of our issues. Thank you. It was a wonderful session, I must say, learning so much about OCR and learning so many things about transcription and this Arabic and Persian script. And thank you, Walter, for all your questions, and also Rohan here. Thank you, ma'am. And thank you everyone for joining us. Today was a long day, but we had a highly, 3 wonderful sessions, starting from Hindi prosody to, digital humanities praxis to finally, rounding up with open Islamic text. This was a wonderful, well-spent day, I must say. Thank you to, our DH team here, Asra and Sarah. Thank you, ma'am. Thank you, all the speakers, from all around the world joining us at, from, different time zones and so on. This was highly, highly fascinating and intriguing, session, I must say. Thank you so much. Over to you, Zara.
Yeah. Sorry, I just want to say thank you all for the invitation. It was lovely to join you, and it was lovely to meet you all. Hopefully we'll meet in person someday.
Sure, sir. Sure.
Definitely.
We are all looking forward to that day.
Yeah, thank you so much, Dr. Miller and Dr. Hakala, for being here with us today despite your busy schedules. And thank you everyone for turning up, and especially to Indrani for moderating the session. Let's meet again tomorrow at our usual timings. See you.
And let's
Oh, right, yes. Our Zoom selfie. Yes.
Selfie. Yes.
Could we all just switch on our videos, please? For
Yes. For all those who are comfortable.
Yes, of course.
Yes. Great. So see you all at 11 tomorrow for Professor Saini's session. And have a good night, everyone.
Thanks,
Thank you so much.
Thanks, Matthew, once again, and thanks, Walter.
Thank you, everyone. Have a
Bye.
safe time. Thank you, sir.